Hi guys, I'm going to go ahead and do a couple of examples from your worksheet. I'm going to go ahead and start with number 2, which says Professor Helen has 184 students in his college math lecture class. The scores on the midterm are normally distributed with a mean of 72.3 and a standard deviation of 8.9. What percentage of students scored above 90.1? How many students scored above a 90.1? So the first thing we have to do is find the percentage, and then we can find the actual number of students. What we are going to do first, though, is draw the normal model. Once I have the normal model, I'm going to go ahead and I'm going to write in the values. So the mean is 72.3, one standard deviation above. I'm going to add 8.9, which gives me 81.2. 2 standard deviations is 90.1, and 3 standard deviations is 99. 1 standard deviation below is going to be 63.4. 2 standard deviations below is 54.5, and 3 standard deviations below is 45.6. So we're looking for the probability that a student will score above 90.1. So 90.1 is right here. So I'm looking for all of this area up here. Okay? And 90.1, so remember that 68% fall within 1 standard deviation and 95 fall within 2. So 90.1 marks that 95, like that 2 standard deviation, the 95 cutoff. Based off of this, because that's the middle 95%, there's 5% left over. If I take 5 and cut it in half, I end up with 2.5. So this would be 2.5% right here. So that means that the percentage of students that scored above a 90.1 is 2.5%. The second part of this question is asking how many students scored above a 90.1. Well, I know that 2.5% of Professor Helen's students scored above a 90.1. So if I take that percentage, 0.025, and I multiply it by the total number of students that he has, which was 184, I end up with 4.6. Now, we actually can't have 0.6 of a student, so we need a whole number. And in this case, I'm going to go ahead and round up, because if it were 4, that would not be enough. So we're going to say that this would be approximately 5 students that scored above a 90.1. The next problem we're going to look at is number 4, which says that 500 values are normally distributed with a mean of 125 and a standard deviation of 10. There's no context here, so we're really just looking at a data set, and they gave us the mean and standard deviation. For all of 4, A, B, and C, I recommend drawing the normal model. So if I do that, we then put in the mean, which is 125, and then we use our standard deviation of 10 to find out that 1 standard deviation above is 135, 2 would be 145, and 3 would be 155. 1 standard deviation below the mean is going to be 115, 2 below would be 105, and 3 below would be 95. I'm actually only going to do 4B for this particular problem, and which is asking us what percent of the values are in the interval from 100 to 150 to the nearest percent. So 100 is going to be about right here, and 150 is about right here. And we're looking for that area in between them. But 100 and 150 are not exactly 1, 2, or 3 standard deviations from the mean. So to figure out this percentage, I actually have to calculate the z-scores first. So first I'm going to find the z-score for 100. So z equals 100 minus 125 divided by the standard deviation of 10, which is a negative 2.5. Then I have to find the z-score for 150. So my data value is 150. Again, minus the mean of 125 divided by the standard deviation of 10, which gives me a positive 2.5. So really here, when I'm looking for the probability that the data value is in between 100 and 150, that's the same as looking for the probability that the area is in between the z-scores of negative 2.5 to 2.5. And that will end up equaling 98.8%. Next, I'm going to go ahead and do number 5, which says a group of 625 students has a mean age of 15.8 years with a standard deviation of 0.6 years. The ages are normally distributed. How many students are younger than 16.2 years? Express answers to the nearest student. Again, I'm going to draw the normal model first. So whenever they tell you that it is normally distributed, it is important to draw the model. So then I'm going to put in the mean of 15.8. And then I'm going to go ahead and I'm going to mark everything off. So if I go 1 standard deviation above, that brings me to 16.4. 2 standard deviations brings me to 17. And 3 standard deviations above is 17.6. Now, if I look, I can see that 16.2 is actually right here, which does not fall exactly 1, 2, or 3 standard deviations from the mean. So I'm looking for the number of students that are younger, so I'm looking for all of this. Now I stopped doing the cutoff values because I noticed after doing just the above ones was that 16.2 was not going to be one of those cutoff values, so I didn't bother with finding the ones below. It's okay if you do, and it's okay if you don't. Since I'm looking for this area below though, that means I'm looking for the probability that x is less than 16.2. Because this is not exactly 1, 2, or 3 standard deviations from the mean, I do need to calculate the z-score. So in this case, z equals my data value is 16.2 minus my mean of 15.8 divided by the standard deviation of 0.6. And this gives me a z-score of 0.67. So then I can either use the table or the calculator to go ahead and find the probability. If I use the calculator, my lower bound would be a negative 99 because I shaded below, and then my upper bound would be my z-score of 0.67. And then this gives me a probability of 74.9%. Now they weren't actually asking for the probability, they were asking for how many students. Well, the total number of students is 625, so the number of students is going to be equal to this total number of students times 0.749, which gives us, rounding to the nearest student, 468 students. And then that would be our final answer. The last problem I'm going to do is number 7C. On number 7, it says to assume that each of the following z-scores are being used with the standard normal model. So just our normal distribution. So in this particular case, for part C, I'm going to go ahead and sketch the model, and my mean would be in the middle, and then they're just giving me z-scores. So -1 would be right here. That would be a +1. Here would be a +2, 3, and then also -2, -3. So I'm looking for the area of in between -1 and 2. So one thing that will be helpful here is to write in the empirical rule. The reason why we want to write in the empirical rule is because we are using the exact values of 1, 2, 3 standard deviations from the mean. I know that 68% fall within 1 standard deviation, 95% fall within 2, and then 99.7% fall within 3. So one way that I can figure out the area of the shaded region is I know that it's going to be the 68% because that whole area is shaded. But then I also have the area in between 1 and 2 shaded. So I need to figure out that area. Well, I know that above 68 or above 1, because that cuts off the middle 68%. So I know there's 32% left over. It has to be even on both sides, so there would be 16% right here. Then I know that above 2, again, 2 standard deviation marks at middle 95%, and again, it's even on both sides, so there'd be 5% left over, cut that in half, and that would be 2.5. So to find this middle area in between 1 and 2, I would do 16 minus 2.5, which gives me 13.5%. So the total area would be 68 plus 13.5, which ends up giving me 81.5%. I think that one is the toughest one that we deal with in number 7. And I think you guys can do the rest on your own. If you do have any questions, please feel free to email or show up to one of the Google Meets, and that would be awesome. All right, thanks guys. Have a great day.